Okay, Isabel, good questions. Okay, tough two questions. The second one is actually easier than the first one, in my humble opinion. Okay, so the first one and the second one. So let's go to work. So records indicate that a particular basketball player scores with 82% of free throws. Bingo. So that also means misses 18% of the free throws. Now, I think you're right in saying, look, it's not a confidence interval, it's definitely binomial, okay? Because, here we go, how many attempts must be made for the probability of missing the goal every single time to drop below 1%? So they are interesting in the number of misses. So here's my logic behind it. N, no idea. P, now we're talking about misses, so that's going to be my p-value. And X, number of misses. That's very important to me. So now I'm going to try and turn this into this statement here. The probability of missing every single goal. So we want X to equal the number of shots, X being the number of misses. And they want to miss the goal every single time. So if they took 10 shots, we want 10 misses. 20 shots, 20 misses. And we want to know what N would need to be for the probability of that to happen to drop below that. Okay, so this is why, and I keep barking on like a madman, why this is so important to us, to understand what our variables are, what our parameters are. And that's why I start going nuts about this. So, X equals N. N successes. So, N successes, none of them, and NC0 has got to be less than that. Therefore, simplifies to that. Now, at this point, I'm going to use my calculator. That's for me, this is the easiest way to do it for me. Okay, different people, different ways. This is mine. I need to see it. I'm quite visual on seeing it graphically. So I'm going to go 0.18 to the power of X, and I'm also going to graph 0.01. Now, I'm going to be very, very careful in my view window. So 0 to, 20 attempts. All right. Now, my Y, I'm going to really reduce it. 0.01. So I'm going to go from 0 to 0.04. That'll do me. Boom, boom. I'm going to draw that. And there it is. There's my point of intersection. Now, I'm interested in when the blue is less than the red. Blue line, red line. Cool. So I'm going to go Shift G solve, intersect, 2.68. Therefore, N is 3. 2.68 is when they meet. N is 3 is the next whole number up. And number of shots are whole numbers. So how many attempts? 3 attempts. Now, if I verify that, if I go back, I'm verifying what I'm claiming. I am therefore claiming that 0.18 to the power of 3, yep, will be less than 1%. Bingo, 0.005. I am at 0.5%. So bingo, bingo, verified. Now, part B, well, determine the number of attempts, N, to be made if the probability of missing at most one free shot, at most one, is less than 5%. So similar, actually quite similar. But we're now talking about the probability of missing at most one. So let's map this out, sketch this out. So if they took 5 shots, X, probability of X. So we could miss none, or 1, or 2, or 3, or 4, or 5. We could miss all 5, yeah? This is helping me decide. At most 1, at most 1. So I've missed none, I've missed 1. That's what I'm after. So that's telling me what to do. It doesn't matter now how many shots I take. That's at most 1. At most 1 means that, less than or equal to 1. And I want the probability of that happening to be less than 5%. Cool. So this is just a little bit more complicated, right? Less than 1 is going to be 0 and or 1. So 0 misses, 0 misses. So that means 0 successes, 0 misses. Oops, again, set of brackets, goose. And 0.82 to the power of N. Or 1 miss. n minus 1, and that'll be nc1, and I want all of that to be less than that. So ultimately, I've got an equation that's unattractive, but, right, I gain, change pen colors to help, I gain, what I'm going to enter on my calculator is x minus 1. Right, I'm going to do exactly the same thing. Get that up and running. Just move this across out of the way a bit so I can read what I'm writing. So I'm going to go back in here, Bell. In I go. Boop. So that equation is now going to be 0.82 to the power of x plus x times 0.18. Stop reading the question. 0.82. Alright, just going to reframe my window. I'll bump that up because I reckon it's going to take a few more shots. I'm going to bump this up to that and draw. Yes, gotcha. Intersect. That's happening at 24.4. Therefore, then when the blue is under the red, the next whole number that the blue is under the red is if n equaled 25. So I would need 25 shots to make that happy. Okay? Again, I don't know about you, Isabella, but I think everything we're doing this afternoon is about getting our head into the game here. And then looking at this, missing the goal every time. X equals n. Because remember, success, we've called success misses. So we want to miss with every single shot, then X must equal n. At most, one free shot misses. At most one. That's where I drew my little picture. There's at most 1, 0 or 1. Boom. And then just having the confidence of going into the GC and pushing it out there. Cheers, bud.